Hello friends, I am Enkijan from Skill on Tech. Today I will explain you about vibrations in centrifugal pumps. Why? Vibration is the biggest enemy of operating centrifugal pumps. It's deteriorate the life of component and reduce the operating life of pump. Therefore, we must know what are the reasons of vibrations in centrifugal pump. Major reasons for pump vibrations. Imbalance in rotating components, misalignment of motor and pump, defective and inappropriate bearings, process fluid leakages, weak foundations, loose structures and suction discharge piping. NPSH available is less than NPSH required. These are the some important reasons and root cause for pump vibrations. So let us discuss in detail in further slides. Imbalance in rotating components. You can see a picture of a worn out pump impeller. This picture is showing you that this impeller is worn out because of cavitation. What are the imbalance regions in rotating components? Pump impeller is not balanced as per grade 6.3 of ISO 1940. So pump impeller shall be balanced as per the grade of 6.3. But generally, if that impeller is not balanced as per grade, it may be a reason of vibration in pump. Non-uniform impeller wear, for example by cavitation or blade breakage, that we can see in a picture. If pump is under cavitation, so impeller can damage, it can wear out and may lead to vibrations. Coupling damage or inappropriate coupling bushes. If coupling is found damaged due to any reason, or if coupling bushes are broken or inappropriate coupling bushes, that may also cause to a vibration in the pump. Bent pump and motor shaft. If pump shaft and motor shaft is bent, its runout is more than the permissible limit. This may also create unbalance and may cause a reason of vibration. If imbalance is found, then what we have to check? We have to check the balancing procedure in the shop. We have to check impeller wear and analyze the origin of wear, and we have to replace the worn out impeller with a new impeller. The shaft and coupling runout shall be checked, and only after getting the runout in permissible limits they shall be installed. If coupling bushes are damaged, they shall also be replaced with new bushes. Misalignment of pump and motor is a very important reason for occurring vibrations in pumps and motors. We have already discussed in detail in our previous video that what is runout and what is alignment and how they may be in a permissible limits and how alignments are to be done precisely. So alignment of pump with motor is not done within permissible limits, may be a cause of vibration. Bad installation or improper alignment procedure, thermal expansion both in pump itself, pump shaft or its pipes. If due to temperature, thermal expansion is coming in the pump shaft or in pipes, that may also put a load on pump and that can create vibrations. Inappropriate or uncalibrated measuring instruments. During the alignment, if we have used uncalibrated measuring instruments, then the alignment may not be in a correct permissible limits due to error in the measuring instruments that will show you incorrect readings. Soft foot. If your foundation and shims which are used for alignment, so that is also a cause of vibrations in the pump. Lack of staff training. If a staff which is carrying out alignment is not trained properly, that may also can commit a mistake in alignment, and that may be a reason of vibration in the pump. When a misalignment is detected in a centrifugal pump, then we have to verify the alignment procedure used and the standards applied. Verify if there is a short foot both of the pump and motor, then short foot shall be removed. Provide alignment tolerance for thermal expansion. So during the operation of the pump, they come under temperature. So that temperature or thermal expansions shall be considered while carrying out the alignment, and tolerances are to be provided for thermal expansion. You can see a picture where alignment check of a centrifugal pump is carrying out with a laser alignment. So laser alignment is a very precise procedure for carrying out the alignment. Defective bearings. You can see a picture of defective bearings in the slide where bearings are damaged. Defective bearing is also very important reason for vibrations in the pump. Vibration in pump may occur if bearing selection and installation is not adequate. You can refer our previous video on bearing selection and installation for the detailed knowledge. Bearing problems are generally improper bearing selection, means the bearing selected may not be suitable for the designed load of the pump. So that can create undue radial and axial thrust and may cause of vibrations. Bad installation. If bearing is not properly installed, defective lubrication or greasing. If bearings are not provided correct lubrication, then that may be a cause of heating of the bearing and will damage the bearing. Hence high temperature. So bearings shall always run under a limitation of temperatures. If bearing temperatures are increased beyond the permissible limit, that will damage the bearing components and will cause of vibrations. How to correct bearing problems? Replace the bearing and make a root cause analysis. Use appropriate bearing as per load and lubricant. Review bearing mounting practices. Check if the operating conditions are suitable for the bearing. Leaks. You can see a picture of a centrifugal pump where mechanical seal is observed leaking. Leaks in centrifugal pump is due to deterioration of mechanical seal due to overheating of the seal when operating the pump without sealant. If mechanical seal is overheated, that may be a condition when it is running dry, means without sealant, so that mechanical seal can damage. High vibrations due to misalignment or imbalance of mechanical seal can also be caused. Bad mounting of mechanical seal and bad seal selection. So these all may be a cause of vibrations. When seal problems are detected in pump, then what we have to do? Check the condition of the alignment and balancing of the pump. Check if the operating conditions are suitable for the mechanical seal. Review mechanical seal installation practices. Prevent the pump from running dry. So alignment, misalignment is a very, very important cause which is damaging mechanical seals. Other than dry running of mechanical seal. Rotating loose parts. In a pump there are many rotating parts like impeller, mechanical seal, shaft, impeller lock nut, sleeve, coupling. So all these rotating parts should be properly fixed in the during the assembly of the pump. If any looseness will remain in the rotating components, that may be a cause of vibration. Bearings generally got wear and tear due to bad mounting, bearing housing wear occur, coupling looseness is one very important reason. When rotating looseness gaps are detected in a centrifugal pump, then check the condition of the bearing. Check if the bearing housing has wear or deformation. Review bearing mounting practices. You can see a picture where check of clearance in a multi-stage pump is carried out. Here you can see a picture of a foundation of a pump. So this is a grouting, and here this is a structural foundation. This is motor, and this is pump. So weak foundation is also one very important reason for occurring vibrations in the centrifugal pumps. The foundation of a stationary centrifugal pump must be capable of absorbing the forces and torques transmitted to it by the pump without shifting its position. The pump foundation shall be solid and concrete weight shall be minimum 3:1 of the pump weight. If your concrete weight is less than 3 of pump weight, then vibrations in the pump will occur. So therefore, for a good foundation, concrete and pump weight ratio shall be 5:1. The depth of foundation shall be adequate to absorb and dampen vibrations. So the depth of foundation shall also be kept appropriate. Steel structures, which we have shown, these steel structures where channels or beams are used shall be appropriate to take load of pump in static and dynamic condition. Structures welding shall be done with qualified welder with suitable structural electrodes such as AWS E6013. We should not use unstandard electrodes for welding of the structural welding. Otherwise, welding joints may fail and may cause of vibration in your pump. Here you can see a picture of a foundation of a centrifugal pump in optimal condition. You can see this foundation is made appropriately. Here it is a concrete foundation, then this is also another concrete slab where these are the anchor bolts in concrete, and this is the structure foundation base of channels, and here this pump is bolted in the structural channels. Similarly, this motor is also bolted in the foundation. So loose foundation bolts that could also produce soft foot and may cause of vibration. Wear of bench supports or silent blocks. If your bench support are wear out, that may be a cause of vibration. If this base plate deform, warped, that may be a cause of vibration. Bad bench foundation. These are the important reasons of structural looseness and may lead to vibration in the pump. Other than mechanical reasons, there may be some important fluid dynamic issues which may cause for vibrations in the pump. So what are these fluid dynamic issues? Cavitation, recirculation, overload, flow turbulence, pump in operation out of design. When hydraulic issues are detected, we have to check the suction condition of the pump, NPSH. The NPSH available shall be always more than the NPSH required for the pump. Check the impeller and pump volute for any damages. Check if the operating condition, flow and pressure are as per the design of the pump. Best efficiency point means pump shall be operated at the best efficiency point. If it will be operated below or above the PEP, that may be a cause of vibrations in the pump. NPSH, net positive suction head, pump cavitation. Pump cavitation is a symptom of insufficient net positive suction head. It occurs when the absolute pressure of the liquid at the impeller inlet approaches the liquid vapor pressure, causing pockets to form of bubbles and collapse at the discharge side of the impeller when they pass through the impeller. So, when these bubbles burst, a heavy impact on the impeller discharge phase will occur and that will damage the impeller. Cavitation identified by the sound of the pump. When pump is under cavitation, you can listen a heavy sound beyond excess noise, higher energy usage and damage to the pump may be observed. Hot water handling pumps may be taken care to meet NPSH requirement. This is very important. When we are handling condensate or hot water, then due to temperature, the NPSH requirement may be little increased. So, a sufficient NPSH must be available than the NPSH requirement. Otherwise, NPSH may be a very big reason for the pump vibrations. You can prevent cavitation by checking the filters and strainers for cleanliness, using a pressure gauge or flow meter to reference the pump curve, re-evaluate pump design if the pump media path is not ideal. Bent pump shaft. A pump with a bent shaft can cause high axial vibration with axial phase differences that tends towards 180 degree on the same rotor. A dominant vibration normally takes place at 1:2 rpm if the bend is near the shaft center. It can occur at 2 rpm if it is bent near the coupling. So that may create a high vibrations in a pump if pump shaft is bent or motor shaft is bent. Bent pump shafts are more likely to happen at or near the coupling. So while checking the runout of the shaft, the particular section shall be checked carefully for measurement of runout. Resonance and critical speed. Critical speed Nk is the rotational speed at which acting dynamic forces cause a machine component such as shaft rotor to vibrate at its natural frequency, intrinsic frequency Fi. It can even result in resonant vibrations throughout the entire machine and pump set. So if your natural frequency of pump shaft or rotor is similar to frequency of rotation of shaft, then there may be a resonance and that will increase the amplitude of vibration. It can even result in resonant vibrations throughout the entire machine and pump set. This effect has the potential to damage fast rotating machinery but can be minimized when such rotational speeds and past are passed through quickly. So these natural frequencies shall be passed through quickly during the operation of the pump. In a broader sense, critical speed is also known as the rotational speed at which the frequency of a pulsating torque coincide with the natural torsional frequency of the shaft assembly. So here you can see in this picture, these are the rotational speeds Nk1, Nk2, and here at the y-axis there is a natural frequency and a rotational frequency of your pump shaft omega, and this is a natural frequency of your shaft, rotor or impeller Fi. So when these two frequencies are matched, then there will be resonance. So we should pass this resonance condition here quickly, so that will not be a cause of vibration in the pump. So these critical speeds shall be passed immediately while operating the pumps to minimize the vibration factor. Thanks for watching the video. If you like this video, hit like button below, share it with your friends and colleagues, subscribe our channel for getting updates on upcoming videos. Please leave any comments, feedback to improve the videos. Thank you.